Okay, we're up and running.
Awesome.
This. Let's see here. The first two are 15 minutes or so each. No, wait. First one's half an hour. The second one's about 15 minutes. Right. You already told me this. Yeah. Can go to 150 if there's a lot of questions. Perfect. That would be me. So how are you feeling?
Ooh.
You.
Good. I'm
Excellent.
feeling good. A bit, I live on a farm in the country, so a bit disconnected, let's say, and hopeful the streaming is going to be okay, but so far so good.
I was about to say, yeah.
What kind of farm?
It's a multi-purpose farm, but mainly we grow cereals and hops or.
Well, I have a hops plant, but it just messes up my fence. It's not like.
Well, yeah, they grow on poles. It looks like a bit of an electrical field, but it's hops growing, and yeah, with chicken.
You must be pretty far south then. There aren't many varieties of hops that overwinter.
That's true. I'm in Prince Edward County.
Okay, so not more north than us in London.
But we are in a microclimate because we're surrounding. I see the Lake Ontario there, and another bay there, and another bay there. So it's like a peninsula. So we haven't had frost so far. So the garden is still in production. So it's amazing.
Cool.
Winter, I miss snow sometimes, but there's not a lot of snow either. So
there's even is there even a winery up there in that little
33?
Yeah, that's what my sister works in Niagara tourism. So so she's taught me something about microclimates and the water keeps things.
It's a magnificent region. I just came here a weekend to discover the vineyard, and I said that's where I want to live. It's just so beautiful. It's perfect in between Toronto, Montreal, and Ottawa. So that's a magnificent region.
Yeah.
Yeah.
The area up there is always stereotyped as being cold because it's north, but yeah, those little microclimates, you just gotta find the right place.
But it's still, it's still challenging for the vineyard too. One year there's a drought, one year there's a flood. Even for us, like farming is not an easy.
I grew up on a dairy farm.
Okay.
That's why I ask you.
Farm. We're just putzing around. Like dairy farm, it's 100.
Gotta work every holiday. Yeah.
I believe you. Absolutely.
It's a hard job. I'm glad that I didn't decide to take it over.
Yeah.
If I farmed, it would be just plants. Anyway, sorry.
Yeah, so we're, I think now's probably half decent time to start. We got a good amount of people show up. I suspect we'll get a few more as we go on. So I just wanted to thank everyone for attending today's session. Today, the first talk will be by Inge Alberts. I'm afraid I probably mispronounced your name.
Perfectly pronounced. Thank you.
Excellent. On an information governance methodology to tackle digital record keeping challenges, the convergence of artificial intelligence, business analysis, and information architecture. They'll be talking for 20 to 25 minutes, after which I'm sure they'll be happy to take some questions. We'll have another presentation afterwards. I'll introduce that one when the time comes. Please feel free to put your questions in the chat and we'll address them at the end. But for now, take it away.
Thank you so much for the introduction. I am absolutely thrilled to be here. As you can see in the title of my presentation, which is quite long, there's a lot of buzzword: artificial intelligence, governance, information governance, business analysts, and information architecture. I put them all there. You'll see the type of work I've been doing is really aiming to bring together, answer some multiple challenges that we have in digital record keeping / information management. I go back and forth with the concept. You're going to see why. So I have a small agenda, but many things to say in this presentation. First, I will give you a bit of a background on the research on this different field and why they are important. And I'm going to give you the objective of this methodology. So it's a bit of a different type of presentation because what I'm presenting you is the accumulation of many years of academic and professional research you're going to see. So I want to talk about this methodology and the different steps and how it's leading now to this new approach to try to automate record keeping. So it's in line with all the new trend of artificial intelligence for information management. And I'm going to talk of some limitation and future development. So the key IAM challenge that this methodology is tackling, and there's 5 components to the methodology, and I would say that the 4 first components are quite solid and well advanced. Now we're working more on the automation component, so there's also some research that has been done. But the idea is now more and more there's a convergence between IAM, information management, records management, IT, and business governance, such as performance management and strategic planning. So all of this is coming together now with this new concept of information governance, because we need an approach that is all-encompassing to manage both structure, which is in database, and unstructured data. So more and more, we're talking of a redefinition of the role of the information manager, which is extremely exciting for us. It's a role of leadership and management. We need to bring these different components of IAM together. More and more so with COVID and the virtual work, the burden on the end user to manage information, I'm talking of corporate information, at their desktop is increasing. So they need to assign metadata, decide what is important to keep, and they are not doing it properly still. So they are busy doing other things. So we have to find a way to help them and assist them with that task. ADRMS, which means electronic document and record management system, they are still a bit in the old world with the folder structure metaphor, where you have to go and put your document in a folder structure. It's rigid. It's not working all the time because it's only placed at one spot in the classification, and user needs to collaborate as well as do records management. And often these two perspectives don't really converge properly. So we also see that automation is becoming a new trend. There was a recent publication of the Records Management Journal on artificial intelligence, but it's still just a partial solution from my perspective, and it has its own challenge. So the idea behind my research is to develop a methodology that will allow for the implementation of a holistic, technologically independent, transferable, and semi-automated approach for the management of both structured and unstructured data in an organizational context. That was a long objective. I'm talking of semi-automation because I do believe that we still need the professional input to train those systems. And also you cannot just automatically apply metadata tag on a document. I still think that we need some validation. And since the end user is a bit the gatekeeper of that metadata tagging at the moment, it will be there to validate the suggestion from the system. So that's the way I see the automation. 4 fields of research are relevant and are converging at the moment. The field of information governance, which is defined by ARMA. ARMA has released a manual for information governance. So the idea is a framework that will cross different disciplines that are concerned with information management, such as law, records management, IT, risk, privacy, security. So all these fields. And what is interesting is that the information professional is at the center of this new trend, and he's the one being the orchestrator of these different fields, and try to bring that and converge that in one framework to manage information consistently. Business analyst has been another trend. I was consultant in my previous life before I became a professor at the University of Ottawa. So I've done a lot of business analysis, and we needed an approach to do this. Borrowing some concept to the field of business analysis was not sufficient to fulfill the purpose. So the idea of the methodology also is to adapt some approach from IM that touch business analysis to improve the identification of the information resource and the determination of which metadata tag to put and what is their value in context. So all of this is borrowed from tools that already IM professionals have, such as the standard ISO, as you see, the practice of doing information audit, all the research on information of business value from the government, macro appraisal. So all of this is also in trend in information management. Information architecture is another buzzword that is important here in the methodology. It's vaguely defined. So one of my students, Xavier Lajulle, did a big literature review to see what were the trend of information architecture in IM. And he realized that it's always, the definition are really vaguely, broadly to talk about how we solve problem with information. What caught my attention is a line in the book of Smallwood, Robert Smallwood, on information governance that talks about the need for organization to have common term, standardized corporate taxonomy, document type, know their relation. So you'll see that even though Smallwood does not talk about information architecture, our approach for information architecture is exactly that idea of that broad perspective on what you have as information assets in your organization. Artificial intelligence is defined broadly also in the literature as a set of technologies that allows to reproduce human behavior. So learn from some information in a data set and reproduce this learning in order to solve some problem. That's really broadly speaking. There's different technique, different typology of artificial intelligence technology. Here it's one, some people would disagree that rule-based systems are part of artificial intelligence, but I put it there. What we use in our methodology and our approach is the rule-based system. So a system that's going to be able to learn patterns in a set of data and apply some rules, and also supervised technique. I'm going to talk about this a bit later, where you use a model already, a category, with category, and you train a data set, and you're able to reapply this predictive model to the other set of the data. So that's mainly what we're focusing on. I'm not the specialist, and that's the great part of this research, is that I'm not the specialist in artificial intelligence. I work with some colleagues at the Cognitive Information Science Research Institute. They are like the techie guys. What I'm a specialist in is in IAM, appraisal strategy, business analyst for IAM. So, and I think this interdisciplinary approach is very important in our field and where we're going to go with these artificial intelligence approach. So there's a few success story in IAM with our artificial intelligence. I put in black two success story is automatic classification and metadata tagging. So that's what we are applying. And also I will say, not to throw some flowers on me, but the appraisal of email of business value, I've done some work with a colleague, André Bellino at the University of Ottawa, and we were able to reproduce some behavior from information management expert in appraising email that have business value, so with a 90% accuracy. So it works. The only challenge we have is that it's very linked to a specific context and a specific situation. So we're trying to develop some method and approach that are more generic, that can be reused and transferable to different professional contexts. So there's many challenges in IAM, and one of them is the opacity of the algorithm. It's very important in IAM and records management to be able to have trust in our information, and you know that. So knowing what the machine, why this decision or why it was tagged like this, why there's this retention and disposition period on information is very important. So we need an approach to be able to keep track of these decisions. There's other part as well is the scalability. There's a lot of small success story, but how can we take a step back and develop an approach that is wider, bigger, and reusable? I see the methodology as some Lego block, and you can use some of these in one organization and other piece of Lego in another organization. So the idea is to try to transfer the knowledge we have from one project to another one. There's also a lot of human cognition involved in record keeping, such as determining the retention and disposition period, so how long to keep information. So if we want to train a machine to do the same, apply the same rules, and they are not clearly defined on the side of the professional, so how we do this? So, and again, I'm not saying that I have all the answer today, but the methodology that we've developed also allow for determining with a series of link and rules between different metadata fields to determine retention and disposition. So this is a way to do it. Also, the data heterogeneity is a challenge. So we need an approach that will apply on top of a series of document type, document source, structured data, unstructured data in different systems. So that's why also the methodology is calling for an approach that is independent from the system and can be just applied on different tools. So I try to be whimsical, and I realized that information architecture and artificial intelligence have the same initial reverse. So it's and it's for me the two same is the two sides of the same coin. Because one of the major roadblocks in artificial intelligence is the need to prepare the training data. So we want to train the data and build a predictive model that then can be reapplied to other data and to automatically classify or to automatically assign metadata tag on document. So using an existing information architecture is paramount, although just developing the information architecture in organization is very challenging. So how we do the first step in order to be able to do artificial intelligence after. So you need to know what you have, know how to describe your information to be able to train your classifier. So I really do believe in a bottom-up approach and not a top-down where you can have categories, because we have discussion with my colleague at the CAIS2020 who are more technological and say, let's just send algorithm and have something come from the bottom up. I think that would be very difficult to do a proper information management practice on a bottom-up approach. So the methodology, the origin of the methodology, so is something that comes from work, academic work, professional work, all the work on information governance from Smallwood, Douglas Laney with the model for infonomics. So important in this idea also of managing information is the idea of the value of your information assets. So you want to target what is the most valuable. And Douglas Laney has very a great line of work. There was some work done, and I participate few years ago to the development of the business approach, a business classification system of Library and Archive Canada. It has been put on a shelf, but it was a function-based approach with macro appraisal. So macro appraisal is a way to determine what has value for your organization based on the function and the business. There's also the work from the Australian Dirks, the manual also embeds some business practice in there. Our standard in records management, which is 15489 and the technical report with it, and then the model of ARMA. We did a lot of work through with my colleague at the CISRI on and some consultant work on how to assess and determine information resource of business value. So all of this was meshing together, and I did a more academic project doing some interviews and cognitive inquiries with a consultant in information management and expert in order to develop a value model for appraisal of information and appraising strategy. So how do you appraise the information? So this is the overview of the methodology, and that could be an entire workshop, a few hours. So I just want to focus on the part that I see more original in the work, because functional analysis has been done in records management since a while, so it's not necessarily original. The process analysis part is more original because it's really developed and tailored for IM purpose and the development of the information architecture that will lead to develop specific requirement for automation. So I think 3, 4, and 5 will be my main focus, but I'm still going to give you an overview of what are the results at the different steps. So this is the more complex version of what you've seen, the little box you've seen in the previous slides. It's just show you how we develop the information architecture. And the idea here is really to focus on the identification of business function and business process. All of these are new terms probably. And on the idea that we want to extract from these business models some facets or perspectives. So facet and metadata are not necessarily the same. So the semantic difference is also, I have debate about this, but we want to identify which metadata needs to be put on the document, develop the control vocabulary that is generic for the entire organization, and then have a set of rules to determine relation and validation between the different facets. So all of this to say that it will inform the implementation of automatic classification or the determination of rules to determine business value. So that's the two line of work that I see stemming from this in terms of artificial intelligence. So this slide is ugly. I apologize. I found an older image that show you the different level. So this is the result of a functional analysis, and it's classic in records management. It's how you organize your activity under main function. What is a bit more original is the process at the bottom. So it shows you that from there, we do a typology of processes from all the organization. And again, even though some function are some processes are cross-functional, we organize the process under each sub-function in order just to be able to do an inventory of the process. This is the approach we take to do at the bottom of the functional analysis, the inventory of our information assets. And it's done in a very information management perspective. You can see on the image, the blue box are tasks, and you have people accomplishing or role accomplishing these tasks. And what is important for us is the information resource that are coming in and out of these different tasks. So it's a way to do an inventory. It's a participative approach where we sit with the main actor of the process, we discuss, we assign business value, we gain their knowledge and expertise of the business, and we also are able to assess the different facets or metadata field that are needed for each process. So in that example, you have an excerpt of a process to preserve or restore some historical piece. So that produce a condition report, but we can have different perspectives such as a type of material use, type of restoration approach. So you can see all of this is the answer for complex information architecture. So I'm coming to this with all the different fields. So information architecture has in the middle the business model with the functional decomposition and the business process. And all on the left side, the intelligence to derive which metadata to assign to an information object and how to derive the value of it through a set of semantic relation and the retention and disposition rules. So this is the vision that we have of information architecture as a generic information model for the organization. So it's linked to the business, it's linked to the information governance requirement, and it has the intelligence to inform the automatic classification or other type of automatic approach to manage information. So it embeds the expertise and intelligence that we need after to train our algorithm. So this is an example of facet. I'm watching my time, so I'm at 20 minutes. It's the different type of facets that can be derived and assigned to the information resource. And from there, we have the different piece of our information architecture, as I explained previously. So from the business model, we have the semantic relation. So we know, for instance, that the conservator will only have access to these type of document in his work. So there's a set of rules there that are already embedded to manage information. We can develop control vocabulary, and all of this is not a big rigid taxonomy. It's a different, it's a series of facets of perspective to describe information, and those can be combined after if you want to develop a file plan, if you want to develop the structure of a website, some metadata field, so you can reuse this component to develop your different tools to manage information and do much more, such as performance measurement. So it has a strong business orientation. The second part is less well-defined. We've been doing some work to train classifier to automatically classify information according to our information architecture and our value indicator. And we're going there slowly but surely. So we've submit a few grant proposals for that. So the idea is that that's the classic chain for training a corpus to learn from a model. So our model would be the information architecture and the different facet taxonomy. And from that, we can create a predictive model and apply that predictive model to a corpus of document. This is fine in theory. In practice, there's many challenges, and that's where we think that we can bring something with the methodology. So one of the challenge of the methodology is the burden to develop the information architecture, which burden we already have anyway in information management. So developing the information architecture is always a lot of work. So we're we start to see pattern in our data, and these patterns can be used also to develop and improve the development of the information architecture. Scaling the automatic classification approach to different contexts is challenging also. So we need generic rules. And there's also the need for explainable artificial intelligence. So there's opacity. And we also think that having that approach with the information architecture will help open the black box. I'm just going to go in here. The future development is the idea is to develop now from there transferable rules and generic models. So the beauty of the thing is we have around 1,200 process map that were developed by information management expert. So we're going to sit down and start developing rules and generic models to be able to have to train the classifier. One of my big field of research is speech act theory and genre analysis, is how I can see in the process that there's process types and there's speech acts, so action that are linked to these type, and document that have value that are linked to this speech stack. So I'm going to be doing this this work on developing a generic typology of a typology of discourse type that can be used to inform the automatic classification. So stay tuned. We're working on this as we're speaking, as I'm speaking, but that will be used then to train the algorithm and hopefully improve the transferability of the approach. I just want to throw a word out there. I don't know how many people are watching this, but automatic classification and artificial intelligence in general is the way to go, but we need to work as a group, as a team. I'm a specialist in information management. There's people that are more specialists in technology and semantic technology. So we really need to build that community of IM experts who can understand this technology and their limitation from a conceptual, from a methodological, and from a technological perspective. And we really need to find a way to really share those success stories and be able to build from there as a community. And my last thought, I'm at 25 minutes. I still want to reiterate that I believe in the semi-automated nature where we still have a role as professionals. So we're not going to lose our job. We still need to make some decision to train the classifier. And also the end user will still have to make a final decision on which metadata to assign in the case of an automatic classification, or if an information resource has business value. It will assist, it will give suggestion, but I doubt that we're going to be able to do a completely automated approach. So we're still very important in the process. So here are some reference. My presentation is going to be online, so you can have a look at this work on artificial intelligence. And this is my colleague from the CAIS2020 who are more like the semantic technology engine experts. So I want to give them credit. Thank you very much for your attention.
All right, thank you very much for your presentation. That was great. We'll take a couple of minutes for some questions, and then we'll go on to the next question. We got a comment here from Leah. I have a background in IA and love this plea for collaboration across disciplines. Yeah. So you are being heard.
Yeah. Can I see the chat? I'm trying to see how I can see
Sure.
the chat.
If we close the screen sharing, it should be easier.
Thank you, Leah.
There we go. And the chat should just be at the bottom there.
Thanks.
All right. Does anyone else have any questions?
So how many people are online? Do we know?
We currently have 13 participants at the moment. So, all right. I think some of us are trying to formulate our questions. Sarah, go ahead.
Yeah, I'm not sure if it's a question, but I just have to say I really like how much data prep and organization is gone into it, even though I don't know anything about business processes. Could you review or a little bit about how, like, what kind of genres of business documents and where you think, sorry, I don't know what the question is. I just really like the metadata organization, but I don't have a question.
So maybe I can extrapolate. The idea is like the theory of genre is a broad theory where you have broad or ill-defined genre of discourse. Like the example of Mikhail Bakhtin is a Russian, he's at the back of the genre theory, and he's saying going in a bakery, for instance, you always have this genre of discourse with this different action, right? You go in, you say, hi, how are you? Weather is nice. Can I get some bread? You get your bread, you pay, and then you greet and you salute. Business process are the same way. They have a sequence of action, and they really look similar from organization to organization. And what is important in business analysis for IM is that they generate information. If there's a step that does not generate information, when I do business analysis for IM, I just don't even record it. So the idea is you want to understand the link between what's happening and the information that is produced. And it gives you a great reveal of how some genres are super well defined, and they're often the one that are the main output and input of a process, like very important. And then there's other decisions that are more communication based and approval by email, for instance, and things like that are really linked to the Speech Act. So I think there's a good amount of work that can be done in there to find some rules that will help the automation process. Am I extrapolating a bit here?
I think that's.
I was just thinking, like, it seems like there's lots of obvious tags or like ways that automation could work with document types, but I wasn't thinking about like where the AI would be useful, but in those communicative emails makes sense. Thank you.
I'm afraid I do have to cut the questions there. We have to move on to the next one, but I want to take a moment and just say thank you for that great presentation, and it will be available online.
Thank you, and I'll stay tuned.
Excellent. All right, so our next presentation is from Blair Frost on AI governance systems, ontological explorations in the Canadian context. Blair, I will ask you to take it away.
Thank you. Thanks everyone for joining as well. Can everyone hear me okay? Perfect. Okay, I'm just going to share my screen here really quickly. That's showing up okay?
Yep.
Okay, and perfect. Okay, so I'm Blair. I'm a PhD student at University of Toronto's Faculty of Information. I've been doing some work analyzing the political economy and governance of AI in Canada. And I'm just going to present a poster today, it's kind of showing two approaches I've been using to analyze the ontology of AI governance systems. So these are collections of instruments, structures, institutions, rules through which AI is controlled. I'll get into some more detailed descriptions of that definition shortly with this poster. I'll give you an overview of some of the components of each ontology. To compare each ontology's strengths and weaknesses, talk about some next steps in the project that I have in mind. And then for the sake of time, we'll leave some open time at the end for Q&A. I'm not going to go too deep into detail about exploration, like the application to the Canadian context of these ontologies, but there is some information about it in the poster. It's a bit of a text-dense poster. I'll actually leave the link in the chat here in case you'd like to follow along while I'm talking about it. And then in the Q&A, if there's any kind of questions about it, I'd be happy to address those then. Just talk a little bit more about the ontologies and the framing to begin with. So the first ontology that I've been using to look at AI governance in Canada is called AI innovation systems. So this is an approach that's synthesized from the economic geography literature, and this focuses on how governance occurs through the production and consumption structures involved in AI innovation processes. So kind of at the top level here, there's 5 dynamic, constantly changing structures that are involved in AI innovation activities. And by kind of looking at some of the patterns of interaction in these structures, you can perform analysis of an AI innovation system, such as the National System of Canada. So I'll just briefly go through each of these structures. The first one, the institutional structure. These are institutions through which behaviors and rules become organized at different spatial and temporal scales. So you can see all the kind of components of that fit into that structure. The technological structure, these are the technological components involved in AI innovation. So you primarily have your data, software, hardware, knowledge, different kinds of knowledge, such as like technical knowledge of how to build an AI system, for example. Infrastructure such as existing electrical or network infrastructure, as well as specific AI applications, be they for industry or consumer applications. Then you have the different kind of geographies through which AI innovation occurs. So these can be international, national, or subnational in the context that I've been looking in. And there's different kinds of systemic effects and emergent behaviors, feedback loops that occur at each of these levels. Sectoral structure. So these are the actors involved in producing and consuming AI services across different economic sectors. And then finally, the governance structure, which consists of different ways to control and change. Oh, sorry, I've got a dog alarm. Somebody at the door. Those are the governance structures are different ways to control and change and direct the governance of AI innovation. And then if you look at the link in the chat, you can take a look through some of the key features of the Canadian AI innovation system here. I'd be happy to go into more detail if anyone's interested in the Q&A section, but it's a bit text dense and I just want to focus on the ontologies for now. So I'll just move on to the second ontology and what some of the components of that are. This is called an AI service systems approach. So this is synthesized from the literature on service science, and it focuses more than production and consumption structures. The focus here is more on how governance occurs through strategic relationships and value co-creation processes between actors. So simultaneously, there's production and consumption going on in this kind of view. The three structures that are of greatest interest here are service ecology, activities, and institutions. So in the ecology, these are the actors involved in providing and using services, the resources involved that are integrated when they interact with one another, and the value networks through which resources are integrated and value is co-created in different kinds of patterns across different times and places. The service activities structure that consists of the value co-creation processes and all the different parts of value co-creation, so the value propositions that each actor brings to the table, potential risks of co-creating value with one another, as well as the outcomes of co-creation. This also consists of valuation processes through which one actor judges and acts upon the value proposition or fails to act upon the value proposition of another actor. And then finally, service institutions are the logics and rules which direct and limit those service activities. So these can be the different strategic intentions of actors. They can be boundaries on action, be they cognitive, informational, or ethical, as well as the rules that kind of more formally on a macro institutional level dictate what's legal, right, or normal behavior. And then again, using this perspective and the language and framing here, some key features of the Canadian AI service system from this ontological approach can be found in the poster. Happy to talk about those in more detail afterwards if anyone would like me to. For now, I just want to kind of focus on the approaches and comparing them. So in really broad strokes, the AI innovation systems approach emphasizes situated knowledge, time, and place, whereas the AI service systems approach emphasizes kind of organizational knowledge, how different actors come together, how they relate to one another in more detail than the AI innovation systems approach. So the focus here is more on networks of exchange rather than production and consumption structures. Kind of integrating them together, the AI innovation systems approach is kind of useful to have first for establishing a descriptive, a broad mapping of a political economy of AI. And once you kind of do the first pass with that, the AI service systems approach is really well suited for kind of deep dives into political economies of AI. So you can trace specific strategic relationships or value flows of interest across several times and places from more of an organizational point of view. And as a result of that, it's much more suited to evaluative or critical analysis than the innovation systems approach, because it's a really good way to be able to, follow the money, so to speak, follow where one value proposition becomes a particular value co-creation outcome between actors, and where the value taken away from that exchange then goes on to another iteration between a different value co-creation exchange between different actors, and how value gets passed along through different kinds of value chains and ultimately value networks over time. So some next steps for applying these ontologies and exploring them more generally that I'd like to take is to try to kind of synthesize them together, kind of what I was talking about in the last part, figure out how like a multi-methodological approach could be taken in a case study that integrates these into, say, like an AI service and innovation system. Then I want to apply these ontologies to some really specific challenges I'm interested in the political economy of AI generally within Canada, as well as in more of a global perspective too. So these are things like resource disparities between individuals and between firms, public-private value conflicts, ethical business models, issues of not just AI ethics, but the business ethics of AI ethics business models, or AI business models rather. And then of course, more detailed case studies of the AI governance systems of Canada and other nations using these perspectives. So that's an overview of the kind of two ontologies I've been using. Happy to address any questions about them or kind of speak to the Canadian context in more detail using any of these framings and get into more detail about a lot of the dense text that I have in this poster. Yeah, thank you.
All right, thank you very much. Well, we got some response in chat already. Leah says, this is fantastic. Such a great way to map out overlapping scopes. And thank you, Blair. Excellent.
Thank you, Leah. Appreciate the feedback.
Excellent. Do we have any questions? All right. I think people might take a moment to formulate them. They might show up in chat, or feel free to unmute yourself and ask away. There we go. Sarah, go ahead.
I don't know. I haven't had a great track record with questions so far.
You can do it.
But I noticed that both of the systems break down the actual resources in the same way. Data, software, hardware, knowledge. How are they differentiating data from knowledge? Is that something you can speak to?
That's a good question.
Do the ontologies do it in the same way?
Yeah, so a lot of it is kind of derived from my own application of the AI innovation system approach. I'm in the early stages of applying the AI service system approach in a similar way. But in applying the AI innovation system approach, I found that kind of breakdown was a really helpful way of describing the key resources that are involved in like developing and using AI, and to speak to like the difference between data and knowledge. In the context of developing and innovating AI, I see the difference between data and knowledge as being data being more so, I guess you could say, like the raw material that's used to train a machine learning model, for instance, or that's being analyzed and creating value through automated analytics, for example. Whereas I would say knowledge is kind of tends to be more on the human side, like the output of that. It can be any number, like it can be on the output or the input side, I guess. It can be, okay, so what do we know now that we've run these automated analytics? Like what kinds of business value could this add? What insights do we gain from that, for example? Or on the input end, it could be, the technical knowledge, the skills of developers, the talent needed to actually develop these systems. And not just developers too, but of kind of in the business context as well. Like the talent needed to be able to kind of gain the resources, like the investment needed, the business partnerships needed to be able to develop these systems, right? So I guess I view knowledge more as being on the human end of the equation, and data more as kind of like, yeah, like a raw material almost. But you're right in that they're very intimately tied together, and that knowledge quickly becomes data, and data is ultimately processed into knowledge for the purpose of generating value. Yeah.
All right, thank you. Do we have another question? We've got another minute or so, maybe a little bit longer, before we want to take our break before the next session. So definitely have at it. I do actually have just a very simple question. You have these two ontologies that you're looking at here. I'm wondering if this is just my own ignorance. Are these the two ontologies on offer? Are there other ones? Do you choose these ones for a reason, or?
As far as I know, there's not really any like systematic like systems ontologies for AI governance systems yet. That's one thing that I'm trying to create with that. As if I'm wrong and anyone knows of them, please do let me know. I'd love to review them. But one difficulty I was having while I was trying to approach these questions of AI governance from a systems design perspective was I wasn't able to find too many kind of systems perspectives on it. So that led me to synthesize these two together from some of the bodies of literature I was already a bit familiar with, economic geography and service science. There's some ontologies that aren't quite as systematic as this. Like they're more focused on developing policy based on a few factors than they are with looking at kind of political economic issues more broadly. But as far as I know, these are the only ontologies that look at, the political economy of AI in like a broader, more systematic scope.
All right, thank you.
Thank you, everyone.
Excellent. So we'll just take a break for about 13 minutes or so before 2 o'clock for our next presentation. While we're here, anyone who wants to have another question for our presenters, I'm sure they'd be happy to chat less formally in the coffee break period of time, unless they have to go somewhere, in which case don't let us hold you back. But otherwise, just relax, talk about your pets. What's your dog's name?
Huxley.
Ah, that's a good one.
Yeah.
My cat's right beside me, and he's asleep, and he's been kicking the couch that I'm sitting on. So.
Oh, it's a little distracting.
Yeah. All right. Leah says that I like your houseplant game. Oh, wow. Yeah, I didn't even notice.
Thank you.
Nice.
It's a little bit overwhelming sometimes. Watering day was yesterday, and it took like half an hour of my life.
Fair enough.
But it's nice. It's nice to have lots of plants around. I like it.
Excellent.
What's the dark green one in the front? Is it an alocasia?
This one, it's an anthurium.
Ooh.
It's just not flowered right now. It flowers in spring, and then the flowers dry up and fall off.
I have an anthurium, but it doesn't look that nice.
Yeah, this is a big one. I got it as a gift from my friend. I've only seen smaller ones before, and she's even more of a plant fanatic than me. So I get a lot of. I'm kind of like her orphanage for when she has too many plants. She'll just bring one over. So she was like, "Do you want an anthurium?" I was like, "Sure, I love anthuriums." And I was expecting a small one, and she just comes out of the subway holding this giant thing with leaves everywhere. I'm like, "Cool, okay." Wasn't expecting that, but thank you.
Also jealous of the ZZ plant, I think.
Oh yeah, that's an older one. That's a ZZ plant. Good eye.
Yeah.
Yeah, I love ZZ plants. They grow super fast, and they're really low maintenance. Impossible to kill, basically. Yeah, great plants.
I got a question. Your various ontologies that you laid out there. I admit I don't really think that I understand them very well. I don't think I'm well enough versed in the literature to have an idea of exactly what they were describing. But it seemed like there was some similarity between that and at least part of what the previous presentation was on. Did you see any connections between the two?
Absolutely. Yeah. What I'm hoping to be able to do eventually with this, a lot of what I'm talking about here in the Canadian context, right? That's a macroeconomic context. And what I ultimately hope that these ontologies can be used for is for analysis of political economic issues at a macro scale as well as a micro scale. So the previous presentation is kind of looking at like the microeconomic level of like firm behavior and how individual firms generate value and co-create value with one another. So there's certainly applicability there. And the service science literature that the second ontology, the service systems one, borrows from, in the service science literature, like the focus tends to be more on analysis of like political and economic issues at like that micro level of firms, and in like process optimization and value optimization at the level of firms and business processes. So I'm trying to kind of create these ontologies in such a way that they're applicable at that scale. Like the AI innovation systems approach, for example, has that macro, meso, and micro layering of scales of interaction, right? But I also want these to be applicable at a macro scale as well, so that you could kind of look at national economies and how the behaviors of individual firms link to national behaviors. Because what I eventually want to do as my dissertation, really the way all this ties together, is to be able to like link those scales together in a multi-case study approach of AI governance in Canada, looking at individual firms, and then different kinds of like research institutions, and then finally like the federal government and their relationship with provincial governments as well as other national governments, how all of that ecosystem functions together.
Sounds like an attempt to model a slice of the entire world. Yeah,
it's kind of going to be a challenging project for sure, and a lot of it is determining like how, like where to take that slice and how big the slice should be. Multiple slices, really, right?
Yep.
And that's why I'm playing around with these ontologies. I'm just starting my second year now, so it's something I'm getting to work on early on, because I know that in a way that's going to be the biggest challenge, is exactly that, like figuring out how to scope these systems, where to do the slicing, and what to look at in the slices that I take out.
I can imagine that if you're operating on those three different levels, the micro, meso, and macro level, there could be interesting interactions once you have a bunch of the micros interacting at the meso level that only really become apparent once there's enough micros interacting with each other in order to,
Yeah, it's exactly that. That's kind of the challenge of the micro level too, is kind of deciding like which firms to look at in which sectors, that could be kind of like the best examples possible for that level. Because obviously have limited time and energy to be able to look at micro level firms like that. But I think the meso level is kind of key there. So looking at different institutes like the Vector Institute here in Toronto, for example, or the new like Schwartz-Reisman Institute for Technology and Society, looking at like, or CIFAR, who runs the Pan-Canadian AI strategy kind of on behalf of the federal government, kind of like looking at what on the firm level, what activity, what firms they work with, what behaviors, what kinds of knowledges they're interested in supporting, and kind of like using their strategy, their engagement strategy, to identify which firms I should be looking at too.
This is a break period, so anyone else who wants to talk is allowed to. Just Ing, if you're actually still there, I would actually like to ask you like the reverse question. Like, what did you think of this talk? If you're still there, if not, no worries. Okay, no worries. All right, well, everyone make sure you get some water and, oh, sorry, I gotta let some people in.
Hello, everyone.
Hello.
Hello.
How's it going?
Hi. Good to see a few people here. Good. Oh, I just realized I should probably get some earphones. I'll be back.
No worries. Just as a heads up for everyone who is here and listening, the next session is a panel presentation, and we're going to be streaming a few of the pre-recorded videos to begin with. Those videos are available on the CAIS website right now. So. Still got a few minutes before anything happens. Oh, there you are, Ing. Actually, I was just going to ask you a question.
Yes.
Yeah, so I was asking Blair earlier what they thought about your presentation. I'm just wondering if you had any thoughts about, like, they're trying to do is like a macro, meso, micro model ontology that accounts for, I'm not entirely sure how I'd describe it, like AI governance, perhaps. And I was wondering if you had any thoughts about how that might tie into what you're trying to do.
Unfortunately, I got distracted and I had to leave for 2 seconds.
Yeah, I know that feeling. No worries. All good. All right. No worries. We're still just on break for a couple minutes, so feel free to talk about anything you like. Actually, were there any questions you were hoping you got, but we didn't have time to? Either of you, any of you? No? All right, fair enough. We don't actually have to chat during the break. We can just...
Alex, I think you can relax. It's a typical situation. People are not willing to chat that much because we are all in the comfort of our own homes, right? I'm just curious where the people are from. I can see some familiar faces. Somebody from Western, I can recognize Ariel. I'm wondering, well, I can see Philippe, I can see Danica, Yemen, but I'm not sure where everybody else is from. You guys want to say where you're from? A couple of words? Yeah, sorry, I missed your talk. I didn't join on time.
Nice to meet you. I'm Inge Alberts. I'm from the University of Ottawa, the School of Information Study.
Oh, wonderful.
I'm saying that with hesitation because now I live in the county, in Prince Edward County, so I'm a bit outside at the moment, but I'm from Ottawa.
Okay. As in Prince Edward County, is it PEI? Is it on the
in between Toronto and Montreal, or not so far from Kingston.
That makes sense. Oops. Sorry, I have a phone call unexpectedly.
Your microphone's still on.
Yeah. So maybe I can ask Blair, how far are you in your PhD?
I just started my second year of it. So that's why I'm like really focusing on ontology now, because I'm trying to figure out kind of how to like scope the case studies I want to do before getting into like a thesis proposal and dissertation next year.
So congratulations! It's a big decision and a big path forward, right?
Yeah, it feels a little bit daunting. Yeah.
During these crazy time too.
Yeah. Fortunately, I was working before I started my PhD at a startup that was almost purely remote. So I'm kind of like used to a lot of like remote working and remote conferencing and stuff like that, but it's just so odd and surreal to just have it be all the time for everything.
Yup. All right.
I can never get used to all of those interruptions. All of a sudden, garage door opening, dryers starting to ring, phone calls interfering, some important meetings, and somebody just walking in or singing out of the basement. Things keep happening to me. I don't know. That's your experience, guys. Sorry, Alex. Don't mean to interrupt.
I'm just saying, I think we should wait like one more minute before starting the videos just to give people a little extra time. So I'll start at exactly 2:01.
2:01 and 0.3.
Yeah. I need to get up the extra 3 microseconds just to keep everyone on
see,
the
well, that gave a chance to Tolu to join us too.
Exactly.
One more time. Right there.
Exactly.
Yeah.
All right.
See some other faces. Hi, Anton. Do you guys usually keep your videos off? Does it provide better quality? Hi, Philip. Nice to see you. What would be your recommendation? What's the
As far
etiquette.
as I know, for the recording, it doesn't
Right.
really matter too much.
Okay, so it's just personal preference, how people prefer to do it. Okay.
I
Good to
think
know.
people have been turning them off during presentations because they can be distracting.
Yeah.
Right,
There's
just sort of back channel, right?
Okay, well, I think that's 2:01, so we will get started. So I want to thank everyone for coming to the third session in the AI session of CAIS. So this one is called AI Opaqueness, What Makes AI Systems More Transparent. It's a panel including Victoria Rubin, Jacqueline Burkell, Sarah Cornwell, Tolu, I always forget how to pronounce your name properly. Your last name. Oh, I think you're still muted. There we go. Thank you. Yimin Chen, Danica Potts-Pollock, and Chris Brogley. So the way this is going to work is we have a bunch of pre-recorded sessions, thankfully so, and we will just be streaming them to you at the moment, but they are available at the website that's already been pasted in chat. That's the CAIS2020 website. And we will just get started on that right now. So just give me one moment. It should already be set up. Here we go. And just a second here. Always technical issues. This worked a minute ago.
Hello, welcome. Thank you for being with us. This panel is part of CAIS2020, which is an open virtual conference for the Canadian Association of Information Science. We will be discussing issues related to lack of transparency in artificial intelligence systems. All the panelists on this panel have either done some research in computation or have studied issues related to social computing or role of technology in the society or quality of data and privacy. We will introduce ourselves as we go. My name is Victoria Rubin. I'm a faculty at FINS, and my doctoral students and I have been working on detection of falsified news and distinguishing with AI systems the differences between the legitimate news and varieties of fakes in news streams. So we have some experience with machine learning and binary classifiers. This is the introductory segment of the panel. It will be followed by 5 talks, and we will follow them with conclusive remarks and open a Q&A session with broader questions to the audience. I will set the scene for this panel by defining AI and machine learning and explaining what we mean by opaqueness in the context of these 5 talks. When people think of AI, many images come to mind, including robotics. In the context of this panel, we're not talking about fully embodied AI. We're talking rather about the technology or machines, computers that are able to mimic humans in terms of their cognitive abilities. For instance, reading and understanding text and making a decision based on what has been learned from data. For example, it would mimic a decision of an expert. Do I want to hire this person or not? And a machine would make that decision based on the personal data in the resume. Or does an instance of an email looks more like spam or not? So we're basically talking about software, we're talking about algorithms, and we're talking about this ability of machines to predict one outcome or another. Sometimes it's called predictive learning. Another term that's closely associated with AI is machine learning. And in fact, it's used interchangeably. Machine learning here refers to computer algorithms that improve automatically through experience, or rather through seeing or processing large amounts of input data, such as text, numbers, images, videos, or behavioral data, such as links, likes, and so forth. So what does a machine learning process look like to a group of developers, for instance? Once the problem is clearly defined, let's say, let's identify spams in email versus the ones that are not spams. Then the developing group would look for data and collect data and put it all together in instances of spam versus not spam. Data would be homogenized or otherwise cleared, prepared for processing with AI algorithms or machine learning algorithms. And this is the stage in which feature engineering could also occur if machine learning is supervised, meaning we guide the machines with some salient features that we believe to be indicators of spam. If there is no feature engineering, no additional data put in as supervised data, then the machine learning would be called unsupervised. So once data is prepared, it goes through so-called black box. It's the sophisticated machine algorithms or machine learning algorithms that could make predictions based on patterns that the algorithm finds in the data that's labeled as spam versus the data that's labeled as not. And once the machine learning provides a training model, then the developers are able to test that model with new instances of data to see what kind of predictions machine would make. And then sometimes there's a possibility of error analysis. Often there isn't, because as I said, the black box is kind of hard to see how the machine arrives to a prediction. And then the main emphasis of a developer, technologist, computer scientist is to go from the problem definition to its solution with maximum efficiency and maximum accuracy. So the main effort here is on solving the problem. What is often being overlooked is how the problem fits in the bigger picture. So we arrived to this curious situation from the developer's point of view, rather a conundrum. Developers do need input data, but they're not necessarily privy to the decisions with which the data was collected. They don't necessarily scrutinize its quality beyond its fit for training models, and they rely on whatever's good enough and available at the time. On the output side, the predictions are made, but they're often binary and they lack classification. Yes, we hire this person, or no, we don't hire this person. But then the mechanism behind that decision, the motivation and justification, is often veiled. It's either inaccessible because there's a myriad of statistical calculations, and it's either not accessible to a human to trace at all, or if somebody were to try, it would be almost impossible because there are so many sophisticated calculations that are made in the process. So developers often search for better models to train their systems with, such as salient features for supervised classification, but may lack the appropriate training or may not have access to broader humanities and social sciences if we're talking about social computing. So the situation on the user side is even more opaque. So let's assume somebody has an information need, looking for a next book to read or a movie to watch, and this user is vaguely aware of the recommender system functions. He or she may or may not be aware of what goes into the input for machine learning, so whose preferences are being considered when he or she is being recommended a movie or a book. So some results are produced, but they're not necessarily explained. No justifications are provided for why this preference might be given to a particular book or movie or a set of them. In addition, the mechanism for how this verdict was rendered is either behind the know-how screen or is just overlooked altogether by the developer. And the general accountability for the system is lacking because it hasn't been explained in a particular application context. What are the governing forces? What are the sort of salient features that went into the decision rendered by the machine? So in this panel, we are calling for greater transparency in AI systems. And why does it matter? So if we were to coexist with algorithm mediation of information in online environments, if we were to accept automated verdicts and make use of the system adopt them and actually follow through with their suggested decisions, we need ways to assess these kind of AI technologies. We need ways to hold developers responsible for the decisions that they offer, even through the mediation of the AI. In turn, these kind of assessments and verifications could lead to revealing flaws in the system, revealing flaws in a broader system that governs the development of AI systems. And that's fine, because the more we learn about artificial intelligence, the more we learn about human intelligence, and we learn about inherently human processes. And the more we are able to provide these kind of assessments and look into verification, the greater the chance of increasing the trust in the systems themselves. This introduction is now going to be followed by 5 mini talks. Dr. Jackie Burkell will talk about external requirements that system outside of the computer science development might impose on the AI system, and she's referring specifically to the judicial system. Danica Potts will talk about internal expectations that users might have from machine learning, especially in the context of categorizing human personal data. Tolu Asubiaro will talk about how we experience artificial intelligence with recommender systems. Sarah Cornwell will address how opaqueness may be built into input data in terms of biases and stereotypes and various ambiguity issues in language. Yimin Chen and Chris Brogley will have a shared talk about one of the examples, the prototype system that we build at the lab to be able to identify clickbait in the news as part of the effort towards news verification in online environments. And they will bring potential solutions towards how a system could be made more transparent. Having said that, we don't have all the solutions. We just have a lot of questions to keep asking, and we're looking forward to your input. After a brief summary of these talks, we'll go to a live discussion on Zoom as part of CAIS 2020. Thank you for your attention.
All right.
My name is Jacqueline Burkell, and I am an associate professor in the Faculty of Information and Media Studies at the University of Western Ontario, and also the acting associate vice president of research. I'm very pleased to be part of this panel on AI and explanations, and what I want to talk to you about today is a particular kind of explanation, or a particular context for explanation, and that is explanations in the context of AI making decisions, making judicial decisions. So what is an explanation? Well, it actually would be more accurate to say what are explanations, or what various forms can explanations take. In fact, when we're talking about explainable AI in a very limited sense, explanations of AI decisions could constitute explanations of or provision of the detail of the algorithms. They could constitute an understandable model of how the system works. They could constitute a list of influential inputs into the decision-making process. It could also constitute, or they could also constitute instructions or information about how a different outcome might have been achieved. That's not a fulsome list. It's not a complete list of the various kinds of explanations that one could provide. But what it gives you an idea of is that what is an explanation is determined very critically by who's asking and what they're asking about. I want to talk about one particular place in which there is a real possibility that AI will be used to render decisions, and in which we already have an existing model of what explanations for those decisions need to look like, and that's the context of judicial decisions. So judges are used to rendering decisions, and in some cases, those judges also provide judicial reasons. Those are reasons for the decision that is rendered. So it provides us with an interesting context to think about AI decisions, and anything we conclude here would be specific to that context. That is, what we understand about explanations in this context won't necessarily translate to other contexts, but it's critical in the specific context we're talking about. And that's something that I want to return to in the end. Judicial reasons have a legal form and function. They set out precedent for the decision. They provide a record for appeal. They demonstrate errors of law. They explain the case law. They enhance certainty in the decision. These are generally legal-facing aspects of the explanation. That is, they're written for and in some sense are consumed by the legal professionals, often lawyers and other judges who are reading the decisions. There's also another function of judicial reasons that is public-facing. These are public accountability documents. They provide a guide to public behavior. Judges are saying to the public, this is how one ought to behave. They respond to litigant needs. They show respect for litigants. They provide litigants with agency and a sense of participation. So the first thing we can recognize about these explanations is that they serve two very different functions. And that's going to be a complexity for an AI explanation that will have to be addressed. So judicial reasons are obvious models for the kinds of explanations we need to provide in judicial contexts, in judicial decision-making contexts. So we can ask ourselves two questions. First of all, how do judges write these decisions? And second of all, how do audiences receive these decisions? So how are they written? These kinds of explanations could be procedural accounts of how a decision that was reached, but they're not. They could be a listing and weighting of attributes. For example, a listing of prior cases, precedents, and a weighting of those as how they contributed to the decision-making outcome, but they're not. It turns out that judicial reasons are more like post hoc justification and support. So the judge arrives at a decision. There was a process at arriving at that decision, but the reasons don't outline that process. What they do is they provide justification and support for the decision that was reached. They appeal to standards, regulations, prior practice, and prior decisions. So they provide the ground on which the new decision sits. They are arguments in support of a decision, not accounts of a decision process. And they are designed to persuade lawyers, other judges, academics, litigants, the general public. So how do audiences read these decisions? What are we getting out of them, we, as not members of the legal community, when we're reading a decision? Well, we're looking for transparency, that is, an understanding of why was this decision reached. We're also looking for these decisions to tell us what is right or to regulate our behavior. So this provides a window in the context of a particular case as to what we ought to be doing. For the losing party, reasons are particularly important. It turns out if you win a legal case, you're not concerned about why that decision was reached. But if you're on the losing side, you are really focused on why this decision and not another one. And in reading those reasons, the public is looking for both sides of the issue to be explained. They're looking for a flow from evidence to conclusion, but not a unified and untroubled flow. They want multiple reasons for a decision. They want an explanation that entertains and rejects alternatives. And they're looking for legal reasoning in those decisions, not appeals to public morality, not appeals to public decisions or public attitudes. That's what we're looking for in the context of these explanations. So explainable AI is going to be important in the context of judicial decisions. Judicial reasons provide us with a model of what explanations of judicial decisions need to look like. And those judicial reasons, both the ways in which they're arrived at and the purposes that they serve, will need to feed back to the production of explanations of AI decisions in the judicial context. Now, a different context will require different reasons. So it won't be that what we learn from the judicial context will translate naturally to every other context. The point is that the explanations we provide will have to be created for and created in the context of the purpose of those explanations. It's not a one-size-fits-all system. Thank you.
Hi, I'm Danica, and I'm going to be talking about explanations in regards to the categorization of people. So what do people want to know about a decision when they themselves are the data subject of an algorithmic decision-making process? So the motivation for this study comes from the introduction of the European Union's general data regulations. Some experts believe that within those regulations, there's this idea of a right to an explanation when an algorithm makes a decision about a person using their personal data. This right is not explicitly within the regulations, but experts believe it can be inferred from a number of different clauses, such as Articles 13 and 14, which say when a person is profiled, they have a right to meaningful information about the logic involved. And then Article 22 further says a decision cannot be based solely on automated processing and requires a right to human intervention in the case of disputes or lack of clarity. Now, seeing as this right to an explanation is not explicit in the regulations, there is no clear definition or guide as to what a meaningful explanation actually requires. Articles 13 and 14 point to the idea that meaningful information about the logic involved is required, but what does that actually mean in this context? What information is meaningful to a person such that they feel like they understand the logic involved in the automated decision-making process? That is what we set out to explore. So, what does the general public expect in an explanation when an algorithm makes a decision about their person? To answer this question, we conducted 21 semi-structured interviews with members of the general public. The only inclusion requirement was that they be 18 or older and speak English. About half our sample were students, both graduate and undergraduate, but we were able to gain the participation of members of the larger community of various backgrounds and demographics. So for the interviews themselves, we would give each participant 2 to 3 different scenarios, such as their credit card was flagged for fraud or they were applying for a job online. And in most of the scenarios, the decision would be made by a system. And the outcome that we would present would be an unexpected negative one, as opposed to a positive outcome, just because that provokes more interest in the participants as to what happened. All right, so before I get into some of our findings, I just want to note that they are preliminary findings based on a sample of 8 of the interviews, as this project is still ongoing. And the first thing I want to talk about is the delivery. And one of the things we asked participants about was extent and complexity. And this is relevant in the case of artificial intelligence and automated decision making, especially because these systems can be quite complex, as we're all, I'm sure, familiar with this idea of a black box, and that as a system becomes more advanced, it becomes more opaque and harder to understand, especially by non-experts. So we were asking participants if they would prefer that the explanation be shorter and easier to understand using layman's terms, or would they want an explanation that was more complex, longer, more robust, and included some of that technical information and technical language. And all of the participants noted that they thought that both types of explanation should be available, but most thought that a priority should be given to a shorter, easier to understand explanation, as they felt that a lot of people would not have the technical knowledge to be able to understand and utilize a more complex explanation. And then we also asked about who they would want to deliver the explanation and in what mode, so like a phone call or an email. And in terms of mode, that was one that varied a lot by context. So it's very context specific. So an example of a credit card being flagged by fraud, most people seem to want a phone call, but in the context of applying for a job, an email or letter seem to be more appropriate. So that's very context dependent, as is who is delivering the explanation. In some cases, participants felt a system was adequate, especially in the case where they felt like they understood why the decision was happening in the first place. But if they had questions or they were unsure of what happened, then they would want to talk to a person. And that seemed to be because they believed that a person would be more flexible and be able to better understand the nuance of their situation and possibly either at least look at the decision more closely or possibly make a change. And then lastly, we looked at timing, which I'll get more into in a moment, whether participants thought that the explanation should come before the process itself or after the decision itself was made. So when we're talking about an explanation that comes before the process itself happens, it's a bit more limited than an explanation that comes after the decision is made because it can't comment on a decision that hasn't been made yet. So information that could be included in such an explanation is information about the process itself, what's the reasoning, what kind of factors are they going to look at, how does that process work. It can also include information about the system itself, what kind of system is being run, who built the system. Participants did note they'd want to be informed that a system was making the decision. That in itself is important. And then you can also look at who is responsible for the decision. So a system may be making the decision, but who's behind that? Who has the final say? Who's programming that system in order to make that kind of decision? It can also include information about data use. So what data do they have access to? How are they accessing your data? What are they using it for? Why are they using it? And who else could have access to that data? Is it being sold to third parties, and what are they using it for? And particularly related to that idea of data use is a couple participants brought up this idea of consent, that they thought that this explanation beforehand was important because they felt like, especially because their personal data was being used, that they should have to provide meaningful, informed consent. And then when we look at an explanation that's provided after the fact, it can provide a lot of the same information, but it can also tell us about why the decision was made. So when participants were asked, what would you want to know in this scenario, almost always they would say, why? Why was I denied credit? Why was I unsuccessful in my application? Why was I flagged for fraud? And what they were really looking for here is what was the deciding factor? What was the singular reason or reasons why I was unsuccessful in this decision process? And that's a little bit different than an explanation that includes the logical process itself. That could include a list of all of the factors that were looked at. How were they weighted? Was one factor more important than another? As well as what data was used, what information was this based on? It would be a more robust explanation. And some participants were interested in that as well. After that initial, what was the reason why I was unsuccessful? And then two other types of explanations that came up was a comparison. So especially in the case of something like an application for a job, people wanted to know, well, what does a successful application look like? What is it about them that made them successful that I don't have? Which is similar to this idea of a counterfactual, which is where you give an explanation of what would have happened if something were different. So, for example, when students apply for credit and if they're unsuccessful, well, what would have happened if they weren't a student? And so all of these types of explanations came up in various scenarios throughout the different interviews, But by far, I would say that so far, the two most important would be the deciding factor or factors, as well as then following up with more information about the logical process itself, which, if we go back to the motivating interest for this study with the right to an explanation in the general data protection regulations, that's one of the reasons why an explanation would be useful in the case of a conflict or discrepancy, or if something's unclear. Then you want to know the reasons why so that you can follow up about that and possibly dispute it. And that is all of the time that I have now, so I will pass along to my next presenter.
Hello, my name is Toluwase Ashubiaro. I am a PhD student at the Library and Information Science program of the University of Western Ontario. And this afternoon, I'll be talking about opaqueness in recommender systems. Of course, I'll just be mentioning two popular recommender systems, and some of the observations in research about the results from these recommender systems. Recommender systems are artificially intelligent systems that recommend or suggest content on content information systems. I mean, information systems that have lots and lots of content, or that suggest or sometimes they suggest items on e-commerce websites. For instance, on YouTube, where there are probably billions of videos, there is a recommender system that suggests or recommends videos to users. Another example is Amazon, which is an e-commerce website. There is a recommender system that recommends items to users of Amazon. Well, these are just two examples. There are other examples of recommender system. Of course, another one is Facebook. And another system that has a recommender system is Facebook. Recommender system on Facebook recommends content, friends, groups to users of Facebook. Now, as I've said, they are meant to, help users, discover items they might not have thought about, help users, to sort through millions and billions of items. Apart from that, they are meant to actually reduce information overload. But let's look at what let's look at the reality. Well, I've actually spoken about the expectations. I mean, what is expected of recommender systems? The expected, yes, the expected. Now, but what is the reality? I will be talking about two popular recommender systems, that of Facebook and YouTube, and how they either keep uh, users further in the rabbit hole, or they actually push users into the rabbit hole. Well, one of the sources of opaqueness in YouTube recommender systems is the data source. This quote is actually from a study by Abu Futu et al. 2020, and it was specifically mentioned that because of the proprietary nature of YouTube, the actual mechanism behind YouTube's recommender algorithm is unknown. This is despite the fact that many papers has been published by Google, I mean scholars from Google, about YouTube's recommender systems. And I'm going to, specifically read an extract from one of the papers from scholars from Google. Now, CAIS2020 et al. 2016 is actually one of the papers from Google, from scholars in Google Incorporation. And in this paper, it was specifically stated that we typically use hundreds of features in our ranking models, roughly split evenly between categorical and continuous data. Now, in the paper, there was a list was not given on what these hundreds of features are. So there is this opaqueness about these recommender systems. We don't know what data these corporations collect from users. There is no explanation about the data they collect from users. And according to one of the earlier speakers, she mentioned that there is a law that states that there should be form of explanations to users, especially when data collected from them is used as part of uh, system development. Now, Google and these other big tech companies actually collect data. We don't even know the data they collect, and we don't know how this data is processed. And sometimes we just get these recommendations from them, especially from YouTube, and we don't know why we are getting these results, these recommendations, that have been, proven to lead people or users to the extreme, Now, studies, I'm just I'm referring to just 3 studies that have actually shown that YouTube recommender system actually lead users to the extreme. One was done on vaccine. This is Abu Fatu is actually recent research on vaccine. Now, Ribeiro was done in 2019 and Tufeki was actually done in 2018. Now, these studies actually show that YouTube recommender system lead users to extreme, but here I'm actually concentrating or talking about the opaqueness. We don't know the data. We don't know how the data is processed. We don't know why we get these recommendations. And these questions, one of the questions that arise is, are these system or is this system still reducing information overload? Well, talking about Facebook, there is this opaqueness about Facebook as well. We don't know the data that is collected. Well, we have some idea of how data is processed, but there is the complex machine learning algorithm part of this that cannot be explained. And I think users actually deserve to understand the type of data that is collected from them, the extent to which this data is used, how this data is processed, and some other questions, I think users deserve to get answers to. Yeah, I want to end my talk with 2 quotes, one from Tufeki 2018 and the other one from the Resta 2018. According to Tufeki, YouTube leads viewers down a rabbit hole of extremism. Well, we don't know how they collect data, the type of data they collect. What we know is YouTube leads viewers down the rabbit hole of extremism. And according to the Resta 2018, rather than pulling a user out of the rabbit hole, the recommendation system, of Facebook pushes them further in. This provokes a question I think we need to ask. are these popular recommendation systems reducing information overload, or they actually increase the problem of information overload?
Hi, my name is Sarah Cornwell, and in this segment of our presentation, I'm going to talk a bit about language data, both text and speech data, and about how the nature of language data and the thickness and richness of language data allows algorithms to reproduce biases. Language data can be thought of as containing multiple layers. You can build language up from the smallest segments of individual sounds or letters up to meaning-containing segments like words, and then larger and larger up to entire works. Works are affected by what medium they're presented in, and they're affected by the larger social context of both the communicator and the intended audience. And these layers are interrelated with one another, meaning that if we have relatively small pieces of information from one layer or another, we can make inferences. We can sometimes make inferences with some accuracy, probabilistic inferences, that is, about the other layers. So if you know that someone uses a phrase like shopping trolley, you could infer, probably correctly, that they are in the British English social context. So what kinds of information can we find in text, written text? Well, the list on the left is some of the things that people try to identify about authors using text, using machine learning right now, with varying levels of success. And this task is called author profiling. While with text data, this is going to be not always accurate, and of course, it is probabilistic. We might immediately realize that there can be issues with trying to extract these ethical issues with trying to extract this data from text. So what kind of issues are there specifically with machine learning? Well, as I said before, the layers interact with one another, but also different features of a text or language segment tend to cluster together. So if you intend to train for one element like age or gender, you may inadvertently train for elements which are strongly correlated with that element. This is a type of bias that can be reproduced in machine learning. As well, different features are politicized or stigmatized differently by different populations. So what a linguist may understand as dialectical difference might be considered simply bad English or an error by someone else, and the way that the machine learning algorithm will treat that information depends on how it is trained. So for example, if you train a spelling correcting algorithm only on English, on American English, of course, it will recognize British English as wrong. And this is especially concerning when we think about the fact that many dialects are stigmatized, even though there is nothing wrong with them. So for example, Black English or African American Vernacular English has special grammatical functions that aren't present in other dialects. One example is called habitual be, where the verb be is used to communicate that a behavior is a habit or regularly done. So the difference between she is running and she be running is that she be running implies that she runs regularly or that running is a habit for her. However, people who aren't familiar with Black English won't necessarily recognize this as an information containing segment and might instead consider it an error. So if we don't accurately, if we don't ensure that our training data represents the diversity and the complexity of the real world context of language varieties, then our machine learning algorithms are going to reproduce the same biases that we have about language when we train them. So this is especially a concern with unsupervised training, because unsupervised training allows the algorithms to choose which features are important, which features correlate with one another, and it weights the features on its own in a black box, meaning that we don't know which features it is using, and we don't know how it is weighting those features, or that is, how strongly it's considering certain features over one another. So if you want to train without supervision, you need to ensure that your training data is diverse enough so that, or that biases are controlled for in your training data. Otherwise, the social patterns of language that exist are going to be reproduced by your algorithm, even if you don't want them to be. So for example, if you are trying to train an author profiling task to recognize men's writing versus women's writing, it may instead learn about men's topics and women's topics and sort people accordingly. But in reality, we can all talk about all topics, so this would be a bad cue and would create a highly biased result. And these sorts of concerns are even more severe when we think about spoken language, because speech contains not just the word itself and the letters, but the individual pronunciation of those letters. And by that, I mean the sound itself, the sound quality, can be measured in a lot of different ways. For example, pitch, timbre, and sonorance. You may have heard of vocal fry or creaky voice, and tone changes or prosody. And all of these things communicate demographic data. They communicate our age, our gender, and our dialect, which can also include features which code for our race, our class, as it were, or at least our class aspirations, and our religious affiliation in some cases. It also gives information about what other languages we speak, how fluent we are, and it lets us know if the speech was done by reading or spontaneously, and it can also encode health information. So this company, as an example, Sond Health, claims that they make 4,000 different measurements on a 6-second voice clip, and they also claim that these 6-second voice clips can be used to monitor a variety of health conditions, some of which are listed on the left. And this is obviously a problem because if we don't know or understand that our voice can communicate these things, then we won't know to teach our algorithms that they exist. So we may inadvertently train our algorithms to be biased against people because of these factors when they correlate with one another. If factors correlate with one another, the machine learning algorithms will relate them to one another, but we don't always want those correlations to be reproduced in the final result, so we have to control them. Spoken data is identifiable, meaning it can be used to identify individual humans, just like a fingerprint. Your voice is unique to you. As an example, the Australian Tax Office uses 120 measurements from a single sentence, and they consider that adequate to identify you just as much as your birthday or name might. So in conclusion, users are often unaware of the quantity and qualities that they communicate when they speak or write. And also programmers can't be aware of all the possible types of things that users might be communicating when they speak or write, and how every one of these factors might interrelate with one another, and therefore have inferences drawn by the algorithms. Our best practices must be to try to examine biases, predict where biases might exist, and then train our machine learning algorithms to realize that even though these features occur together, they should actually be treated independently. As well, we need to ensure that we use quality data that adequately represents the full diversity of human speech if we want our algorithms to also represent the full diversity of human speech. Thank you.
Hello, my name is Eamon Chen, and along with my colleague Chris Brogley, I'll be speaking about a project that we've been working on at the Language and Information Technology Research Lab at the University of Western Ontario with Dr. Rubin, Sarah, and Toby. Technology Research Lab at the University of Western Ontario with Dr. Rubin, Sarah, and Tolu, some of the other presenters who you've already heard from in this panel. And this is our clickbait detector as an example of more transparent systems design in natural language processing. So as you've heard from our previous speakers, one of the biggest issues with AI is that users and often even the programmers themselves aren't completely sure how it all works. You've got a bit of a black box problem where you feed in the data and then magically computer science happens. And then you get some kind of output. And this output is, of course, often useful on some level. Otherwise we wouldn't do it. But without having at least a decent grasp of how we get from point A to point B, we can't be fully confident in the results. After all, how can we trust a decision if we don't understand how it was made? And so one of the ways in which we can increase the explainability of systems is, for the user anyway, is through transparency. And this goes beyond simply telling people what the inputs are. They also need to know essentially how the process works as well. So they need the answers to questions like, what is the system doing? What parts of the input data is it paying attention to? And of course, what are the conclusions based on? So essentially, what we should try to do is to open up that black box as much as possible and sort of allow people to have a peek inside. And of course, also some user-friendly visualizations of the results doesn't hurt either. So this is a screenshot. The example we have today is our clickbait detector, which is part of the literal news verification suite. So this system was designed to take in headline text from news websites to then determine the level of so-called clickbaitiness that is present. So clickbait is defined as, quote, content whose main purpose is to attract attention and encourage visitors to click on a link to a particular web page. And generally, this type of content is seen as low quality, exploitative, and quite often a contributor to the spread of misinformation. My colleague Chris will be giving a demonstration of the clickbait detector in just a moment, but this screenshot shows some of our efforts, at the very least, in creating an understandable color-coded interface. So as you can see here, green is good and not very clickbaity, whereas red is heavily clickbaity and therefore, kind of bad. So like I said, it's important that the processes are transparent and understandable. And for our part, this has meant publishing the details of our work in a number of publications over the last couple of years, as well as releasing the source code of our systems on GitHub. And of course, while the sort of finer points of the system may not be entirely understandable to users without a computer science background, what I have here on this slide is a list of the top 20 out of 38 textual features that our clickbait detector looks at in order to make its decision. So here we have things like the number of pronouns, number 1 there, for example, or the presence of profanity or vulgarity, which isn't on this page. It ranks a bit lower at number 28. As well, adverbial phrases, number 6 there, are a common example of hyperbolic exaggerations and has proven to be fairly predictive. And several of these features were informed by earlier work that we've done at the Literal Lab, part of which involved asking human news readers about how they identify and perceive clickbait articles. So in essence, the purpose of this is to, show our work, if you will, to present the reasoning that our system uses in making its decisions transparently. And so that user can then understand what's going on and thereby have some basis to judge whether or not they should trust the output that they receive from this system. And so without further ado, I'm going to be turning it over to my colleague, Chris Brogley, who will be doing the demonstration part of this segment.
Hello, and welcome to this demonstration of the Literal News Verification Browser. To start with, we'll use cbc.ca, a news website, to take a look at the clickbait detector features. This detector works by analyzing the links on the website to determine whether or not it thinks that they are clickbaiting or not. In the window on the bottom right, the color-coded bars represent the number of headline links that are considered to be heavily clickbaiting, moderately clickbaiting, slightly clickbaiting, or not clickbaiting at all. The detector also gives an overall rating for the page. In this case, this page is moderately clickbaiting. If we return to the browser window, we can scroll down and see all the headlines, which are also color-coded, in this case green for not clickbaiting, and here red for heavily clickbaiting. Let's go on to another website known for its clickbaiting headlines, BuzzFeed.com. In this case, the detector thinks that the majority of the headlines are heavily clickbaiting. And if we scroll through the website itself, we'll see that all the headlines are highlighted in red. Next, let's take a look at how the satire detector performs on an article from The Onion. Let's take this one for example. Students who take Latin have better chance of summoning demon later in life. We'll switch the toggle over from the clickbait detector to the satire. This detector works on longer passages of text and gives its rating as a percentage. In this example, you'll see that the detector is 75% certain that this article is satirical. This concludes our quick introduction to some of the features of the news verification browser. Thank you.
Hi, so I think Yimin just finished his portion of the video. Thanks, Yimin. So my name is Chris Brogley. I'm a PhD student here at Western. I'm going to be showing you some software that our lab worked on that is an example of how we were trying to be more transparent with our use of AI and machine learning, really, to classify different types of deceptive texts on the internet. Okay, so I'm going to open up the literal browser here, and we are going to take a look at it as one example of a system that does try and be more transparent. And one of the first things that pops up when you use this, if you download it, it's on GitHub. I'll show you the page before I finish here. It does say that this is experimental research software. It's not perfect. The research that we do, and there is a paper linked to the GitHub page for the browser, it says we only tried it on so many clickbait texts, so many satire texts, so many falsification texts, and that it didn't get 100% accuracy on those. So I've set the home page of the browser to be to a file that I saved on the hard drive, and this file just contains some headlines that Yimin used in a previous study, and I just wanted to show you how this software does make an attempt at being more transparent, and then we'll move on to looking at a more real world example of the FIMS news page. This HTML page loaded, it's on my desktop, and I thought we would start with this headline, seeing as how you know, Halloween is right around the corner, so Aubrey scares the stuff out of children on Halloween. And it got a big red rating from the clickbait detector. It just said 100%. And then there's some other headlines here too. So these ones were all rated as clickbait. The last two, well, it did get a yellow score, so that means it's clickbait-ish, but not too much. And then the non-clickbait, most of them came up as green. There was only one yellow, and that's what we would expect because these were classified in a previous study. So let's take a look at the one with Aubrey here. I mean, why did that get classified as clickbait? So what we can do is we can go over to the results view here and then double click on the text that we're interested in. So I'm going to double click on it, and then it comes up with the Clickbait Explorer, which shows you all of the features that we use in our machine learning classifier, and also all of the values that they had for this particular text. And while this page doesn't show you exactly why the clickbait detector decided that, you know, Aubrey scaring children on Halloween was a very clickbaity text, it does at least show you the values that were passed into it in order for it to make that determination. So that's what we've done here in an effort to try and be a bit more transparent. We actually just have all of the values here. And kind of building on this, one of the things that this software wanted to take advantage of with respect to the transparency of just showing you everything that we're doing for the machine learning classifiers. When you start getting video recommendations, they're not showing you any data or, you know, any site that's using any machine learning, they're not going to directly show you the values that they're using for the machine learning because they don't need to. And so that leaves you a lot of time wondering, well, how did it come to this conclusion that this is what I wanted to watch or listen to, etc. And so here, because this is a research tool, we're completely transparent with all of it, and all of the values are here. So what we can do with those values is actually save them all to a database with this browser, and you can do research on them. You can work with those values, you can do statistics with them, and so I'm going to do that now. We will go over to the analysis, and I already made a data set, Halloween, and I'm going to save the results to the data set. And it said 11 clickbait results saved, and what I can do is I can go to our stats panel and click on timeline view, and then click on clickbait and get some stats, and I'll set it to my desktop site. And this is actually giving us a graph as to like the minimum clickbait scores, the average clickbait scores, the maximum clickbait scores. And we're able to do this all because of the transparency with respect to the values that we're passing into our machine learning classifier. So we just list all those features being like measurements of the text in this case, and their values, and then we can save them to a database, and we can actually start analyzing them, looking at them over time, and basically doing research with them. And that's the whole point of this browser. So I'm going to go to FIMS News next. So we will head over there. That's pretty much how the browser works. And one of the nice things is, and if I want to, research just how clickbaity they are or how not clickbaity they are, I can go to analysis. I've got my Halloween data set up. I want clickbait measures, and I press save. Yeah, there we go, 311 clickbait results. And that is saved to a database file. So you can take that and open it up in other programs. And if we look at the FIMS news page, we can see the scores of the clickbait, and we're able to obtain this all because of the transparency, and we're showing all of the values, and we're also able to keep a record of them. So if you're interested in this software, you can go to the GitHub page, our GitHub page. It is github.com/literal. That concludes my part of the video, and I will see everyone at the panel. Thank you.
Hi again, this is the concluding segment of our panel for CAIS 2020 on AI opaqueness, what makes AI systems more transparent. I hope you enjoyed our mini presentations, and at least we've given you some food for thought. We would be very happy to hear your feedback, and individual panelists would be happy to answer your individual questions. I would like to leave you with a brief overview of what we've talked about. This panel has addressed the issue of opaqueness in AI, as seen in input and output of machine learning algorithms, and as seen in external forces such as legal system requirements, and internal forces such as expectations by users of such systems. The issues with input data, especially as expressed through language, are biases, stereotypes, and language vagueness, and they persist nowadays. The internal mechanisms are typically that of black box. Machine learning is so complicated that it typically cannot be understood by users quite often. Neither can it be accessed by developers because such systems require multiple statistical calculations. The output quite often is opaque because it lacks explainability or interpretability of why the decisions were made and how they were made. So what is the basis of the salient features that went in the input of the machine learning training? Often the outside forces, the outside world dictates system requirements, but justification is rarely provided in the user interface, so the traces cannot be steps cannot be retraced by users. So these are sort of the main premises of what we talked about. We also offer some solutions that should be sought to rectify some of the problems, and hope that the audience of the CAIS 2020 conference can offer some of their thoughts and solutions. We talked about using open access for sharing the code to disclose the technical details of algorithms. In the demo example that we've given, we've used GitHub. there are other ones as well. We talked about the second solution as using conference proceedings to disclose the input feature, to disclose the social feature engineering if it's supervised machine learning, and disclose the efficiency and accuracy of the results from the computer side as well. We talked about more work that needs to be done in the human-computer interaction for the usability, explaining the results, the justifications, the feature disclosure, the tracebacks, to go around that black box issue. And another solution that we can think of is, of course, greater collaboration between the technologists, the people that develop these kind of systems or use them for development of predictive modeling, computer scientists, and so forth, with the humanities and social scientists. So these are briefly some summative remarks. And here are some references of the works that you will see in the full text PDF. We'd like to leave our audience with three broad questions. The first one has to do with instances of AI system opaqueness in information profession. The second one has to do with solutions, initiatives, and perhaps concrete efforts or ideas for solutions. And the third one has to do with broader grievances or concerns with the socio-technological situation in which computers are mediating our decisions. I'd like to elaborate on each one of them. So for the first one, in terms of instances of AI opaqueness in LIS, as we all know, LIS has been actively organizing, curating, managing information for our users for ages. It was and continues to be a mandate of information profession. It used to be the mandate in the pre-computer age and pre-social media age, pre-AI age, and it's perhaps even more important nowadays with active use of AI systems or for the work of database managers and other experts in the information profession. So my question is, have you, as an information professional or an academic or an expert AI user, run into these issues of opaqueness that we've talked about, whether it's at the point of algorithmic treatment of input data or at the point of the output with decision making, or perhaps with the mediation of communication with patrons or users? So where should LIS systems require greater accountability, if you can think of any instances? So that's number one. Number two has to do with solutions, initiatives, and efforts, concrete ideas. So if you do know of instances of opaqueness in AI systems, perhaps you don't know some solutions. We would like to hear from you. What do you suggest could be done to improve the situation? If you can get very concrete, that would be helpful. Or if you have general ideas and speculations, we'd be happy to hear from you. Especially if you're part of any initiatives and efforts that are already underway, it will be interesting to our audience. The third question has to do with broader grievances. More broadly, how comfortable do you feel about the involvement of AI in decision making? And should, in principle, technologists and computer scientists be collaborating more actively with humanities and social scientists, in your view? Perhaps for ethical and moral considerations. Perhaps there are other gaps that should be filled with the kind of disciplines that are not trained for accuracy, precision, and efficiency. So we'd be very happy to hear on these 3 points, and I'll leave it at that. Thank you again for your attention.
All right. I want to say thank you very much for those recorded presentations. That was fantastic. I'd like to open up the floor to any questions that people might have. Looks like there's some comments in the chat already. Oh my, there's quite a bit in here actually. Let's see here. If anyone wants to pop up and ask a question right away, feel free. I'm going to try and find the beginning of this. Okay, so as to the two different user presentation videos on the clickbait detector, it was just being noted that the first one where Yimin was narrating, that was an older version that was less focused on the transparency aspect. The video that Chris narrated was much more about the transparency considerations. We've got a comment here. It would be nice to make a Python package. As I understand, there are lots of technical considerations that go into any project like this. It's difficult to decide which way to go. And once you've gone down the road, maybe Chris wants to speak to that.
Yeah, I can respond more to that. Yeah, I think that's a good idea, but I think the focus was on making these tools accessible to like anyone, not just people with a data science or a programming background. That's something that we can look into, though. I think the development or further development on this is probably going to be done by different people, and maybe that's something that they could look into, because the detectors are just basically Python command line programs, so that we could do a package that would just be a little bit more work. And then I think the other thing that you pointed out, Olha, was what was the second thing? Oh yeah, you said that the problem is that different people would not agree on clickbaitedness. It is a human problem. Yeah, and actually in the browser, it lets you disagree with the clickbait detector outputs. So you can actually, I didn't show it in my video, but you can right click on the rating results, and it comes up with a window that lets you say, here's what I think that the score should be. And then you can actually rate, okay, did the clickbait detector do a good or bad job? And then when you save it to the data set, that goes into your database file as well. So yes, I agree with you. And we had some features in there for that. You can actually try it out. Yeah.
I would also recommend checking out the specific clickbait article, which I'm trying to find, which gets into how we tried to deal with the fact that there isn't an agreement on what constitutes clickbait. So instead of labeling headlines as merely yes clickbait or no clickbait, the corpora actually was built on a Q sort where people arranged all of the headlines according from least clickbaity to most clickbaity. And then we had a number of people do it. It was a small data set, but I think the quality of the inter-rater reliability in that really helped to get our clickbait accuracy up. And I will try to link the paper in chat when I find it.
I also want to point something out. I think the fact that we're even discussing the notion of clickbaitiness is interesting, because application of AI opened us up for the discussion for something, as you all have pointed out, is innately human, something that has controversy within the society. So there are some costs to transparency. This is something that is also known as AI transparency paradox. The more a model's creator reveals about the algorithm, the more harm could be brought in a malicious attempt. Also, there is more exposure to backward engineering the clickbait. So if somebody wants to come up with a perfect clickbait, they would surely look at everything that's been studied, especially over large amounts of data and patterns, to see what constitutes a clickbait. So that could stimulate this kind of an AI race where you would look for other creative ways to avoid the algorithm that knows how to pick it up, go around it, yet to grab the person's attention and still bring them back to meaningless content. So there are costs, and it's an interesting interaction between artificial and human intelligence, just as a side note.
Also,
you can also turn this question around in a different way. There are lots of people who are trying to write good tweets that will catch a lot of attention. So this can be used for writing tweets.
we trained it specifically on news headlines. And I think that testing it on tweets would be, well, one of the corpora did use tweets, news headlines that were tweeted. So there is some tweet stuff in it already, but yeah,
also,
definitely.
Another thing that I want to add that there are different levels of users. There are users who are not familiar and would not be interested to download any data. There are users who are more advanced. Also, there are different levels of machine learning. Machine learning algorithm can have error on its own. And even a developer cannot explain, it can explain, he or she can explain the error, but the error could be invariance or something else, which will not be that intuitive to the end user. Another thing, the bias can come from the sample. Then the bias can be in the data. With regards to YouTube, it's an interesting question whether YouTube users are creating these interest groups and are dividing into echo chambers, or the algorithm is pulling them in. I talked to some people who work for Microsoft, and they are saying that using AI algorithms just to classify, it's okay. What is more problematic if someone develops a control system that will pull you either into one class or another class. And I don't see, from the results, I don't see that this is actually happening. This could be just affected by users. And users actually do create lots of groups, lots of fragmentation, segmentations. If you analyze a very large number of tweets or a large number of likes of newspapers, they form groups. So, you know, it's a complicated issue to explain.
I think you're right, even though there are a few issues that you're conflating a little bit, Olga, but I wanted to point out that, yes, we are aware of various kinds of users. We have received requests from librarians, for instance, from University of Guelph, in which they sought to be able to download this browser and use it in their information literacy campaign to explain to students how to use it. We also have received recently, a couple of weeks ago, right, Tolu, a Nigerian teacher who didn't have any programming background and just wanted to download and play with it. Yeah, so that's why one of the presentations, Chris's, was more targeted towards the research side, and Yemen's presentation was towards the user side. I don't know if anybody else wants to pick it up. Anything else from what Olga
Well, actually, I would play
about?
with tweets, but I have millions of tweets, billions.
I just made a Twitter account, so I'll have to try out your idea on Twitter for the clickbait detector. But yeah, just going back to what you were saying about, like, there's different groups of things. Like, yeah, I think there's probably more research needed on probably all of these topics for like all those subgroups, I think, if I understand what you were saying earlier. But yeah, anyway.
I can show you some of the things that we've done with interactions of, because you see, in information retrieval, we usually look at one person, two people, like small groups, but we never look at collective behavior of all people, of what is going on at a collective level. And at a collective level could be something completely different, what you don't expect, because people self-organize into groups. It's a different level of behaviors that we often overlook in the information science.
That's part of what I was trying to get at with the language as thick data, is that we organize ourselves into groups and we don't even necessarily realize that we're giving away those group affiliations in the data. I think there's a question from Philip as well.
I have a comment concerning the use of clickbait detector for tweets. The detector was actually trained on stories that are paragraphs. They have paragraphs, and one thing I've seen about computer models for knowledge representation is stores that are made for sentences will not work well for stories. and stuff for stories will not work well for sentences. So for instance, Facebook has its own knowledge representation model, the Doc2Vec model, that's for documents. Then there is Send2Vec, which is for sentences. So for tweets, I don't think the clickbait detector, which is meant for analyzing news, will work for tweets. Tweets are like few characters long, few words long. So I think that you may need something different for tweets.
Yeah, I saw that, you know, I could customize it to some degree. I would play with it, but you see the tweets
Olga,
that
I
I'm
was
working
wondering.
with.
Sorry. I was just wondering if somebody wanted to take in a slightly different direction.
Yeah, going back to the opaqueness stuff.
Well, Philip's had his hand up.
Yeah.
We might be able to let him speak for a moment.
Thank you. Excuse me for redirecting the conversation. I'd like to thank the organizers and the panelists for a fascinating view. It was quite wide, but deep enough to be really satisfying. So thank you all. A difficult task. The question I have really focuses on what Jackie was discussing earlier. And in particular, I was wondering if the adversarial nature of the English common law system under which both Canada and the US suffers as well as enjoys, it reduces complexity in a way that in many other applications may not be possible. At the same time, in judicial decisions, the stakes are very high. People's freedom, their economic status, their social and political status are at stake. So I wonder if Jackie might have comments about that, please.
I think all of that goes to the point I was making about context. So yes, the stakes are very high in the judicial system, and particularly if you have AIs making judicial decisions. And so the accountability requirements are increased. Interestingly, however, I find it fascinating to think about this, that in the judicial system, reasons are not always provided. In fact, for the large majority of decisions, there are no reasons. So it's interesting to think about the possibility of using AI to make judicial decisions. I have worries about that. But if you did, and you managed to create a system that created reasonable explanations, and reasonable in the context, that is, explanations that satisfy the needs of the context, then you might be able to provide everyone with an explanation. I mean, as to the particular nature and of the sort of the judicial system and the court interactions in Canada and the US, they absolutely determine they determine the kind of argument that's reasonable. They determine the kinds of explanations that are required. But I think that's exactly the point I was trying to make, that if you're going to create explanations that have value in the real world, then you don't get to decide what constitutes an explanation. It turns out that in many contexts, it's already determined for you what constitutes an explanation. And it really doesn't matter what you, the developer, thinks, or what anyone else thinks. It's like you need to look to the system for an answer to the question. So really good points. And as interestingly as I'm actually writing a paper on this right now, and as I'm looking at the literature on XAI, it turns out that, so the original literature on XAI is just saying, oh, we have to explain, and we can do it by transparency of algorithm, or we can do it by listing the, identifying the relevant input data, we can do it by testing counterfactuals. But the literature is coming around to the point of saying, oh, none of that's actually going to work, because what we have to do is pay attention to the social psychological research and the context to determine what do we need to do for an explanation here. And then once we know that, we can figure out, I believe we'll be able to figure out how to produce those explanations.
Technically, we are out of time, but if anyone wants to stick around, or the presenters want to stick around and answer some more questions, I think this is a fascinating topic, and a lot of people would probably want to keep on talking about it. But we are technically over, but I think everyone's sticking around for at least a little bit. Okay. In which case, oh, well, a couple of people are running. All right, fair enough. I do actually have a question that might build off of what Jackie just said, which is I'm wondering if there's a possibility of using XAI as like some sort of framework in the opposite direction. So instead of trying to use it to replace human explanations that are offered, we can sometimes recognize that human explanations are themselves not very good because humans confabulate things. They create post hoc explanations that don't actually represent what was going through their mind at the time. And will the effort to create systems that are robustly explainable maybe give lessons back the other direction in making humans explain themselves better? I don't know. It's just a thought that occurred. If you have any thoughts.
Well, something like related to that actually did come up in the interviews, because sometimes I would say, like, would it make a difference if a human was providing the explanation, and what would you expect? And this is just anecdotal, but it seemed to be that people would often expect less of a human, and they would, especially if we like started talking about bias or whatnot, they're like, well, of course people have that. And then they were talking about how people have like some kind of intuitive social relationship based on these different social factors that they don't necessarily expect to be explained to them, that they just kind of know is happening and will accept that that's this like undercurrent part of the decision that's made. So I don't know if this really answers your question about whether it will make human decisions more explainable, but it is interesting that, at least in what I saw in those interviews, people tended to seem to have a higher tolerance for less explanation from a human than they did from a system.
I also think I think there's a long and complicated answer to that question, and I don't think it is natural. I don't think it's an automatic outcome that AI system and an exploration of XAI is going to create better human explanations. But I think it is possible to imagine ways to use AI and the principles of XAI to create better explanations or to create better decision-making processes. And one of the things I'm thinking about is the work that's been done on algorithmic bias. And the algorithmic bias is a really big worry in most decision systems. And in fact, because the bias is baked into the data that we're using, it's not clear to me that any algorithmic solution is going to be able to remove the bias. But there are algorithmic processes that can expose bias. And that's interesting. So if you're, if you're looking at bail decisions and you're working with data that are inherently biased because historically those decisions have always been biased, and you can't remove the bias from your decisions because you're basing on old data, you can actually test for it so that you could reveal it, and that might create a better decision process. Who knows?
All right, thank you. We just got a comment here from Leah. Just this morning, Meredith Broussard said we need an FDA for algorithms. Interesting.
Yes, and that's, yeah, we absolutely do. And probably that's on its way.
In the same literature along the XAI, which I don't really like using, Jackie, because it comes from DARPA from 2016 program. I don't like the whole XAI movement, but there have been studies trying to explain building system that would explain the system decisions to users in human ways. University of Washington has one that's called LIME. And what they did, they looked at what Sarah was talking about, and she was talking about language correlation factors, but they looked at something that's more visible. They were trying to show the differences between wolves and huskies and how the system came up with a decision. And what apparently the system picked on was the availability of snow. So if there is snow, then it's a wolf. And if there is no snow, it's a husky. And it wasn't quite apparent because sometimes visible objects are not quite easy to pinpoint. So I'm more concerned about the spurious correlations. Not only that, I'm also concerned about layers of algorithmic errors. Something that has been known in natural language processing forever is that the closer you get to that circle that Sarah
kind of cut out there. Yeah, I'm afraid we've lost.
Word to sound or sound. Is it cutting out? Okay. Okay. All right. So I was just gonna say that if you notice what Sarah had is she had the speech recognition running along with her. So it was almost error-free. There were a few errors, and that's considered to be a simple problem. The larger you go into the meaning, into the pragmatics of it, and that's what linguists would consider, any kind of application, meaning pragmatic use of language, including law, the more likely you are to encounter all sorts of little errors that will build up. So by the end, you get to the actual decision at the level of societal implications with biases and stereotypes. There will be various correlations like snow and huskies or no snow huskies. And there will be so many errors that by the time you reveal the deciding factors, the humans might not even trust the decision. Totally for FDA, for algorithms. Okay.
Most of that last comment, but all right. Any other questions or comments? And from the presenters, anything else that you want to just mention or feel particularly proud of?
How do I get that background, Yemen?
Oh, yeah, that's cool.
I think everybody did really well with their recordings. My two last words is know thy data. I think that a lot of the time nowadays, data is disconnected, or the collection process is disconnected from the task in AI. People grab data, crawl, or sort of grab it to see instances of something they think is in it. In fact, they may not be able to find what they think they're looking for because the data were not collected properly and didn't stem back to the research question properly, so that you don't end up with topics on the properties of their speech. So know thy data. That would be my last 2 cents. I don't know if anybody else has anything.
I actually made a slide, which I had to delete for time, about, trash in, trash out. And I use the example of the Scots language Wikipedia. Has anyone heard about the news coming out of that? Essentially, Scots is a language which is related to English, but not English, that's spoken in Scotland. And they have their own Wikipedia page, and it has over 45,000 articles. So if you wanted to train a natural language processing algorithm to read Scots, you would think that that would be a great place to start, until it was revealed that last month that over half of the articles were written by a teenager in the United States who isn't fluent in Scots. And all of it is fake Scots. It's just an American teenager typing with a Scots accent. So if you aren't familiar enough with what good data looks like, it would be really easy to fall into those kinds of traps.
Wow. We have some comments here from Philippe. We need to free ourselves from categories and embrace probabilities and distributions and transparency. There's no real reason for opaqueness. Categories are only an illusion of precision, and they also marginalize. That seems like a very categorical statement there, Philippe. Sorry. All right.
I seem to have an ongoing conversation about definitions, whether definitions are useful or not with most people.
Well, what's your definition of a definition?
Oh, don't ask me that, please. I wouldn't make Philippe happy. It would have to have some categories and margins in between somewhere there.
Fair enough. Well, unless there's any other pressing questions, we've gotten an extra 10 minutes of Q&A time, so that has been great. I think we might be all wrapped up. Any final thoughts from anyone? No.
All
right,
Thank you everyone for coming.
Thank you.
All right, so in that case, I just want to once again thank all our presenters from all three presentations. The first one, the poster presentation, and the panel. That's quite a lot of people talking about a lot of interesting content for the day. And thank you everyone who stuck around for that entire time. So that's been fantastic. And I hope that we'll see some of you for our very last case session, which is next week sometime. All right. In that case, I am going to. Oh yes, I also really want to thank the organizers of all this. Philippe in particular has done an amazing job. The other people working on the case project as well. I don't remember all of them off the top of my head. Let's see here. It was Grant Campbell, Leah Brown, and Roger Chabot, which Kelsang Legden. So thank you everyone, and I'll